Hey everyone, and welcome to this explainer. Today, we're locking down the definitive 2026 standard operating procedures for safe HVAC servicing. We're going to follow the exact life cycle of a technician on the job, walking you step by step through the latest guidelines and mandatory practices. Look, whether you're managing a whole crew or you're out there in the field yourself, mastering these procedures is absolutely vital. Why? Because the transition to new, highly flammable refrigerants has completely rewritten the rulebook for our industry.
All right, here's our roadmap for today. We'll be covering preparation and safety, identifying your refrigerant type, the essential tools you need for diagnostics, handling those new flammable refrigerant gases, and finally, the step-by-step service method. Let's jump in.
Section 1, Preparation and Safety. Let's talk about the stakes before you even touch a valve. So, every job starts before you even reach the unit. We are way past just throwing on some basic work gloves, right? Your PPE absolutely has to match the specific modern risks you're facing on site. You need ASTM D120 rated insulated gloves, specifically for electrical panels, and iOS certified respirators for handling refrigerants or working in poorly ventilated zones. And flame-resistant clothing, that's a must-have now when you're working around combustion systems. It's really all about equipping yourself for the exact hazards of the 2026 landscape. Now, beyond what you wear, it's about what you do. Electrical safety is still a massive concern, which means strict lockout/tagout or LOTO procedures are completely non-negotiable. It's a rigorous process. You systematically identify all electrical energy sources, lock them out with designated devices, and apply warning tags with your name and the date. But you know the most critical step? Using a certified voltage detector to independently verify a zero energy state. Oh, and the technician has to keep that lock key in their pocket the entire time. No exceptions.
And hey, we can't talk safety without looking up. With a recent spike in OSHA violations and injuries during rooftop work, mastering fall protection is critical for compliance and, honestly, for your survival. You need full-body harnesses with self-retracting lifelines, and you've got to stick to the specific metrics. Maintain the 4-to-1 ladder angle rule, that's 1 foot out for every 4 feet up, and make sure your fall-arrest anchor points are rated to support at least 5,000 pounds. Annual refresher training on all this is highly recommended now.
Moving on to Section 2, Identifying the refrigerant type. This is your diagnostic phase. Picture this. You walk up to a unit. The manufacturer's data plate on the side panel is faded, or maybe it's just completely gone. How do you know if you're dealing with older R22 or the newer R410A without risking a dangerous blowout? You have to know for sure because virgin R22 has been banned for servicing in places like the EU for years now. That means it legally cannot be recharged.
Well, age is your very first clue. Pre-mid-2000s, it's likely R22. Installed between roughly 2005 and 2024, that usually points to R410A. And anything 2025 or newer is going to be an A2L, like R32 or R454B. But here's the thing. The pressure gap between these is huge and incredibly dangerous. R410A operates at 26 to 31 bar on the high side. That is 50 to 70% higher pressure than R22. This is exactly why mixing them will literally crack fittings and violently burst an R22 compressor.
Which brings us to the golden rule for the diagnostic phase. Whether you're doing a serial number lookup on the manufacturer's portal, checking the compressor tag, or using an electronic identifier tool, never, ever guess the refrigerant type. The consequences are just too severe. You're looking at compressor failure, oil sludging, and severe safety hazards, especially with the newer A2L gases. Section 3, Essential Tools for Diagnostics. Let's get equipped for precision. For modern technicians, what's the best gear? Honestly, a mixed setup usually wins. You want to rely on your analog tools for basic service environments, where they can take a bit of a beating. But you absolutely need digital tools when the job calls for faster readings, high precision, and clear documentation for compliance. Just keep in mind, those digital tools require regular calibration and careful storage to keep that pinpoint accuracy. The core of your setup really comes down to a few non-negotiables: a professional-grade manifold gauge set, a powerful vacuum pump for moisture removal, a dedicated refrigerant recovery unit, and a precise charging scale. Notice I said professional grade. Entry-level gear just breaks down. These tools must be perfectly compatible with the specific refrigerant you're working with, especially flammables, to ensure accurate charging and a safe, deep evacuation of the system. Section 4. Handling flammable refrigerant gases. Welcome to the new reality. There is a massive shift happening right now.
As we look at the safety classifications, you can see we are rapidly moving away from the safe, non-flammable A1 group, so gases like R22 and R410A. Instead, we're shifting up to the lower flammability A2Ls like R32. And in some applications, we're even seeing highly flammable A3 hydrocarbons like R290. Full safety checks are required across the board, but these new classes, they demand ultimate respect.
Handling these new gases safely starts with proper containment. You absolutely must use the specific compliant cylinder for the exact gas you're recovering. The safety mechanisms, the pressure ratings, even the thread types differ wildly between an R32 tank and an R290 hydrocarbon tank. Putting the wrong gas in the wrong tank is basically a recipe for disaster. And please take this warning seriously. Never, ever use an open flame for leak testing on these new systems. Not only can it cause instant ignition and a literal explosion, but specifically with R32, exposing it to high heat or an open flame forms hydrogen fluoride gas. That is a highly toxic, corrosive substance that will cause severe respiratory damage if you inhale it. Stick to electronic leak detectors or bubble solutions, always. Section 5. The step-by-step service method. Time for execution. Okay, let's break down the actual process. Before you even think about opening a refrigerant circuit, you must perform a standing pressure test. You do this using an oxygen-free dry nitrogen cylinder to safely track down leaks without releasing any refrigerants. Once that's fixed, you evacuate the system safely using a 2-stage vacuum pump, bringing it down to a deep vacuum. And only then do you proceed to precisely charge the system using your digital scale. When you're setting up your vacuum pump for flammable gases, routing is everything. The suction hose gets securely connected from the piercing pliers straight to the pump. But the crucial part is the exhaust vent line on the vacuum pump. It has to be safely routed all the way to an outside area. This guarantees that any residual flammable fumes pulled from the system are exhausted completely outdoors, rather than filling up an enclosed room where a single spark could set it off. Now, what about venting? The rules depend entirely on the gas. Because R32 has a moderate global warming potential, it is illegal to just vent it. You must always use a recovery machine. Hydrocarbons like R290, however, are a little different. While a recovery machine is still preferred, they can legally be safely vented directly outside. You'd use piercing pliers and a long hose with an extractor fan, provided you're in a completely safe, ignition-free outdoor area. And that brings us to our final thought for this explainer. The entire industry is abandoning non-flammable gases like R22 and R410A. It's no longer a matter of if you'll encounter these flammable systems, but when. So the question you really need to ask yourself today is this: are your standard operating procedures truly adapted to handle the explosive risks of tomorrow's refrigerants? Take this knowledge, update your SOPs, and make sure every single technician comes home safe. Thanks for watching.